Hello guys. Today we are doing the final lesson of chapter 8. So what we did is 8.3, 8.4, 8.5, and 8.6. And you may remember from previous chapters that the whole reason we learn all this computation stuff earlier in the chapter is so that we can get to equations that have these things in them. So today we're doing the whole purpose of learning all those operations on rational expressions and the purpose of like finding values that can't be is all to solve equations. All right, so you need to know what a rational equation is. So a rational equation is an equation in which the variable is in a ratio. So that's why it's called rational. And a ratio is a fraction. So you could think of it like it says fractional equation. So if you think back to the previous chapter, we had exponential equations where the variable is in the exponent. We had logarithmic equations where the variable was in the log. And now we have rational equations where the variable, it all depends on where the variable is. The variable's in a ratio. So if the variable's in an exponent, it's exponential. If the variable's in a log, it's logarithmic. If the variable's in a ratio, it's rational. All right, so if you look at this, this is a rational equation because the variable is in this fraction. This is not a rational equation because the variable is not part of the fraction that's in this equation. To solve this one, all we gotta do is add a half. So x would be 3.5. So this is not a rational equation. This one is. All right, so there's all sorts of different ways to solve rational equations. There's something called clearing fractions. There's this way where you get the bottoms to match and then all you have to do is set the tops equal. But the method I've found the least problems with is getting it to where there's just one fraction on each side. Sometimes they start that way. And then you just cross multiply. Now there's some solving after that, but that's the gist. The gist is that you get one fraction on each side. This one's already set up that way. This one's not. This one's not. One fraction on each side, and then you cross multiply. So since this one's already that way, we're gonna cross multiply, cross multiply. Whenever there's an x squared, I like it to be on the left, so I'm gonna do this one first. 5 times x squared minus 1. Now I'll distribute that in a second, but that's how you multiply it. And then here, we're gonna do 15 times 2x minus 2. So it looks like that. So we're cross multiplying here, we're cross multiplying here. I like the x squared one to be over on the left. All right, now I'm gonna distribute. 5x squared minus 5, distribute. 30x minus 30. And then since we've got an x squared and an x, I'm gonna move everything over to the left and I've got myself a quadratic. So I think I'll do that in purple. Subtract 30x. There's not any x's over here, so it's just gonna squeeze in right here after the x squared. And then I'm gonna move the 30 over, so I'm gonna add 30. If it bothers you to do it all in one step, you can do this separately. I'm gonna add 30. So now that whole side cancels off and everything's moved over here. So let me write this down. I'm gonna write it up here. So I've got a 5x squared. I moved the 30x over, so it's minus 30x. And then I moved the 30 over. I had a negative 5 or a minus 5, and I'm adding a 30, so that's plus 25. Equals 0. It's 0 because I moved everything over to the left. That left nothing on the right. Okay, notice they all are divisible by 5, which makes this an easier question. I can factor out the 5. 6x plus 5 equals 0. Now I'm solving, so that 5 is like it's gone because you can divide that side by 5 and divide this side by 5. I'm not going to write that, but you can get rid of that 5 by dividing both sides. And so all I need to do is factor this guy. And since there's no number in the front in there, that's not too bad. So write down all the ways to get a positive 5. 1 times 5 That's it, right? But I want it to add to be -6. So I need it to be -1 times -5. See, that still multiplies to be +5, but I'm wanting it to add to be -6. So the numbers where it factors, when I break this down, is -1 and -5. So x minus 1, x minus 5. The reason I covered over that x is because it's not like there's a number in front and here where you have to do master product. It was already factored out. Okay, so to solve each one that has an x in it, remember you just set those equal to 0. So you're thinking back to that factoring chapter where we solve quadratics. So x minus 1 equals 0, x minus 5 equals 0, x is 1, x is 5. And if you don't have to show all that work, that's okay. Some of you remember that whatever makes this 0, so it's the opposite of that. Opposite of -1 is +1. Opposite of -5 is +5. So you don't have to show all that work if you remember that shortcut. Okay, now, in the original problem, okay, there are some restrictions on the variable. Remember that you can't have 0 on the bottom. So if you plug in a 1 right there, see, I found out that x is 1. If you plug in a 1, 2 times 1 is 2. 2 minus 2 is 0. And we would have 5 divided by 0, and that's undefined. So this is one of those restricted values. So x can't be 1. Even though I found it using all that correct work, that's not a solution that, that I can keep, because there's something happening at the graph right there. And in this case, it would be an asymptote. And then here, I got x is 5. If you plug in a 5, it's okay, because 2 times 5 is 10, and 10 minus 2 is 8. And then if you plug the 5 here, 5 squared is 25, minus 1 is 24. So it's all good in both of the bottoms of those. So x equals 5 is the only solution to this equation. You have to double check these to make sure they aren't holes and asymptotes. Okay, so now it gets a little bit harder. If there are two fractions on one side, we have to combine those two fractions. Now I said combine because sometimes it's a plus and sometimes it's a minus. So it all depends on that operation. All right, so think back to last lesson, 8-5. To put these together, since there's a minus, you have to have a common denominator on the bottom of the fractions. So getting those combined is going to take a little work. That's the hard part, actually. So here's what I do. I just kind of ignore this guy for a minute. I ignore that side. And I just pretend I'm in lesson 8-5 and I'm adding those two things together. Well, in this case, subtracting. Okay, so to make them common, they both already have an x. See, so they already have that in common. It's just this one needs what that one has. So this one needs a 5 times 5 times 5. And this one needs what that one has. So this one needs a 2. Now remember, we're multiplying. Top and bottom. Whatever you do to the bottom, you have to do to the top. Okay, so what we have on the top here is a 5. What we have on the bottom here is a 10x. What we have on the top here is a 4. And what we have on the bottom here is a 10x. Now, if these don't match, what we were doing here did not work. Okay, so the whole purpose of what we were doing, sorry, that just was ugly a little bit, was to make these match. All right, so once they match, you just keep that same bottom number, 10x. Do not subtract them. It's just, that's our common denominator. This is what you subtract, 5 minus 4, that's 1. And then now I can remember that I have another side to this thing. And now I'm ready to cross multiply. This one is much easier because there's no squares. So sometimes they're kind of easy when you cross multiply. 10x times 1 is 10x. And 1 times 2 is 2. And then divide by 10. And your answer is 1/5, 2/10, 0.2, whatever form you prefer. If you did it in a calculator, 2 divided by 10, you can write it like that, 0.2. Okay, let's make sure this does not put 0 on the bottom of a fraction. So the original fraction had 2x, and 2 times 0.2, that's okay. 2 times 0.2. See, we get 0.4. That is not 0. See, we just can't have 0, that's all. And then 5 times 0.2, 5 times 0.2. You get 1. So if I put 0.2 there, I get a 1, and that's good too. That's not a 0. What we can't have on the bottom of fractions is 0. So this answer is good. All right, last one. So again, I'm going to cover up that side. Now sometimes you'll have another kind of fraction over here. But I'm just going to cover up that side, and I have to subtract these. Sometimes that'll be a plus, but again, I'm subtracting on this one. All right, I have to make these match. One common mistake here is some people think they can just put a +1 and a +1, but you can't do that. You can't add to both the top and the bottom. You have to be multiplying by something, okay? So to make this match, you can't just put a +1. We have to give this one what that one has. This one has an x plus 1. So I need to give the bottom of this fraction an x plus 1. Whatever you put on the bottom, you put on the top. X plus 1. Sorry, I know that's small, guys. And so this one has an x and an x plus 1. This one just has an x plus 1. So now it needs an x. 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 All right, so here's what's happening. If you look at the bottom, they match. They both have an x plus 1. They both have an x. That's what's on the bottom. And I'm going to write it like this. X times x plus 1. The order doesn't really matter. You could have the x at the end. This is just normally what it looks like. Sorry, I'm losing power on my phone. Hopefully that didn't cut out. Okay, on the top, ooh, there's a lot going on the top. Okay, x plus 1 times 4, the 4 distributes. Because I want to be able to combine it with this. So 4x plus 4. See, 4 times x is 4x. 4 times 1 is 4. And then that's a minus. Don't forget that's a minus. Subtract 3x. Now, if there were multiple things here, I would need to put that in parentheses to distribute the minus. But since there's only one term, 3x, you don't have to put parentheses around it. Equals 1 still. Okay, now I can subtract that guy. I can do 4x minus 3x. So that is x plus 4 over this stuff equals 1. Okay, 1 is the same as 1 over 1, and now I can cross multiply. So cross multiplying x times x plus 1 times 1. Anything times 1 is just the same thing, x times x plus 1. And then x plus 4 times 1. Again, anything times 1 is just itself, x plus 4. Okay, so since this is x times x, this is a quadratic. So I'm going to have to distribute this to solve this. X squared plus x equals x plus 4. Ooh, this just became nice because look, when you subtract x from both sides, the x's cancel on both sides. So you have x squared equals 4. I thought for a minute I was going to have to factor all that, but since the x is canceled, you can just solve this square right here. So to undo squaring, you square root. X is positive and negative 2. Remember when you're solving radicals, when you're solving equations, you got to put both. Okay, go back to the original equation. The original bottom was an x, and 2 on the bottom is good, and negative 2 on the bottom is good. So they're both good there. And the original bottom here was x plus 1, and 2 plus 1 is good, and negative 2 plus 1 is good. So neither one of those values made 0 on the bottom of our original problem. So they're both good answers. All right, that is how you solve rational equations. If there's two fractions on one side, you got to put them together like we did in lesson 8.5, and then you cross multiply. If they're already a fraction equals a fraction, just go ahead and cross multiply. All right, so that is the end of what we're going to be doing in chapter 8. That is all. Bye, guys.